at the end of the first semester, we talked about 1D motion. Now we're going to talk about 2D motion. So when we talked about one-dimensional motion was either up and down or it was horizontal. Okay, so vertical or horizontal. Now we're going to combine the two things and make 2D motion the two different things. So 2D motion refers to the movement in a plane. Okay, not an airplane necessarily. We're talking about the planes, the X and Y axes. Okay, so it involves the two dimensions, horizontal and vertical. Okay, so examples are car driving on a road, going up and down, a ball thrown, a ball hit, a ball shot, a ball kicked, a golf ball hit, whatever. All of those things, they're going to go up and then they're going to come down. And then they're going to go further away depending on speed and whatever other other forces have been put into play. So keeping that in mind, how do we show movement? We show movement by drawing vectors, okay? And vectors tell you both the number and they tell you a direction. And they are essential for describing motion, okay? So you have displacement, you have velocity, and acceleration are all vector quantities. Remember, it's magnitude and direction. If I said to you, car is traveling at 72 miles per hour north, and then is traveling at 72 miles per hour northeast, is there any change in the velocity?
Yeah.
Why? How? There is, but how? What changed? The number didn't change. The what changed? The direction changed. And when direction changes, that means the velocity has changed. Okay, something acted upon it that is now making it go northeast as opposed to north. Okay, so that means an unbalanced force has come into play and has done that. So, review. Distance, displacement versus distance. Distance is the total path traveled, while displacement is the straight line distance from start to finish. Displacement can be positive, it can be negative, and it can be zero. Distance cannot be negative, okay? How would you calculate displacement if you walked in a circle? You would count all your steps as you go all the way around. All right, so velocity is the rate of change of displacement and is a vector quantity. For the x-axis, it's the change in x over the change in time. And for the y-axis, it's the change in y over the change in t. Or the change in y over the change in time, yes. So just keep that in mind as we talk about velocity. And we're going to get into this. Everything is very similar. We've already done a lot of how we're going to do this. So it's going to, it will make sense as we get through this. So when we're drawing vectors, that's your graph, right? We know that this is 0 degrees. We know that this is 90 degrees. This is 180 degrees. And this is 270 degrees. This is east. This is north. This is west. And this is south. Do you know what north, south, east, and west are? What are they called? Say it again? No, not ordinance. They are directionals. What specific directional are they? They have a name. Anybody know? They're called the cardinal directions. They are the cardinal directions or directionals. Okay, because they're the main ones. All right. So, if I draw a vector here, that say has a measurement of 17 degrees. What way is that vector moving? Just up.
Northeast.
So it's moving northeast, but is it moving more north or more east?
More east.
So how would you write that as a direction?
17 degrees.
Okay, so the angle is 17 degrees. And what's the direction?
East.
Just east?
Northeast.
Is it east, northeast, or northeast?
East. East north.
East north? Here, I'll get you off the. It's east northeast. Because what do we know? Each quadrant, right? So these are all quadrants, right? This is what? Quadrant 1, quadrant 2, quad 3, quad 4, right? We know the quadrants. This vector, which direction is it moving more in? East. It is moving upward, but not as much as it's moving to the right. Okay, does that make sense?
Yeah.
Okay. So when we describe any motion, we have to make sure we are as accurate as possible to be able to do that. So what do we know about each one of these quadrants? How many degrees are there in each quadrant?
90.
Right, 90, right? Because we know each one of these are right angles. So what would be the midpoint of the first quadrant? Angle-wise. What's the halfway point?
60.
No.
30.
No.
Of the east and north one?
Yeah, what's the midway point right here? What's the angle degree? If it's not 30 and it's not 60, well, how would you find it out? First of all, you would do 90 divided by 2. What's half of 90? Oh my God. 45.
Okay.
Oh, good Lord. 45 degrees. So, how would you describe that directional at 45?
Northeast.
Why?
Because it's more up.
It's moving up and to the right at the same amount.
Yeah.
So it's going, because it's right in the middle of the quadrant. So this is northeast. Okay? Anything here is moving east-northeast. So from 0.1 degrees to 44.9 degrees is moving east-northeast. Okay? What do you mean?
I don't understand what the numbers mean, and I don't.
So the angle is the angle at which the vector is moving. So it's this number right here.
Yeah, but how do we know that?
A lot of times you're going to be given it in the problem itself.
But then what does east northeast mean? Like,
That's the direction it's traveling. So it's traveling. So the 17-degree one is traveling more east. So east has to be represented more than just north. Because it's going more, it's going further out than it is going up. So in that case, it's east-northeast. So everything here, up until 45 degrees, everything in here is going to be moving east-northeast. All right? At 45 degrees only, it's moving at northeast. Then, from 45.1 degrees to 89.9, all of this is moving in what direction?
Northeast, north.
So, yes, but you would do it as north-northeast. For whatever reason, the vertical cardinals are paired together. The horizontal are split. I don't understand why. It makes no sense to me. But yes, it would be north-northeast. Okay? At the 90-degree angle, you're moving north. Okay? So as you come around counterclockwise, what would be the midpoint of quadrant 2?
2. 90.
No, that's the axis.
45.
So it's 45 degrees is the midpoint because you know every quadrant is 90. But what would the angle be? Coming from here, if you were measuring from the 0 axis, the positive x-axis, what would this angle be? It's not negative. What's 90 plus 45?
Oh, it's a clock, so it'd be like.
Yes, it's counterclockwise, so it's 135 degrees. So it's 135, that's the midpoint, is 135. Okay, and that means this would be moving northwest. Okay? Everything in here from 90.1 to 134.9 degrees. Everything in here, if a vector were to fall in here, everything in here would be moving north, northwest. Okay? Now, your midpoint's 135. You're going to come here. It's 135.1 to 179.9. And everything in here,
West, northwest.
yes, good, Aiden, is moving west, northwest. Good job. All right, so as you go through, like you get a feel for it, it kind of makes sense, but let's keep going. So the midpoint, again, 45 degrees, right? Because everything's 90. So what would the angle measurement of the midpoint be in the third quadrant?
20.
Plus 45. So what would it be?
225.
Yes, 225 degrees. And what would the direction be?
West, southwest.
It's the midpoint.
West, south? Or
Southwest.
Southeast.
So that would be southwest. Now, so from 180.1 to 224.9, everything here in the third quadrant, what would the directional be?
West, southwest.
Good. West, south, west. Good job. So from 225.1 to 269.9, what would that directional be?
South, southwest.
Good. South, southwest. Yo. Yeah, make a tag, make a pass. All right. And then we draw the midpoint here. What's it going to be?
I can't do this math right now.
So 270 plus 45 would be what? Well, 5 plus 0 is 5. What's 7 plus 4? 315, good. So it's 315 degrees, right? And then what's the directional? If this is southwest, what would that be?
This one, this is south, southeast.
It's the midpoint.
Oh, I keep forgetting we're going to midpoints right now.
So southeast, okay? So now, to your point, from 270.1 to 314.9. What is all of this going to measure at directionally?
South, southeast.
Yes, south, southeast, good. And then we're going to come over here. This is going to be 315.1 to 359.9. And what'd you say, Ken?
East, Southeast.
East, southeast. Good. Good job. Okay. So that's that. That's this one. Okay. So you have the idea. The midpoints are going to be the 45s, and that's where you're only going to have 2 directionals there. Everything else, every other measurement in the quadrants are going to have 3 directionals with them. Only the midpoints have 2. So you can see at 45 northeast, 135, 90 plus 45 is 135 northwest. 180 plus 45 is 225. That's going to be southwest. And then 270 plus 45 is 315, and that's southeast. Okay? All right. So let's look at this one. This is what I want. Okay. This is not what I want, though. Let's go new. Save. Okay. So, angle 41. Angle 41 degrees in counterclockwise from east. Draw the representative in nearest axis form. Okay. So, a couple things here. Number one, draw your graph. So we're going to do it over here. So there's your graph. So from the east, so keep in mind, 0 east, 90 north, 180 west, 270 south. Okay? So keep that in mind. So the total angle is 41 degrees. So here's what we do. We start here, right? We start on the positive side of the x-axis, and we go 41 degrees, just short of halfway, right? It's just short of halfway. Draw your vector, label your vector, 41 degrees. Okay, now, what's the first question you ask yourself? Did it make the midway point?
Yeah.
No.
No, it did not. Did not make the midway point. So what is your directional going to be?
East, northeast.
Good. It's east, northeast. So when you come over here and answer these questions, so keep in mind, 1, 2, 3, 4. What quadrant is the angle?
The first one.
Good, 1. Okay. What's the degree? What's the number?
41.
Good, 41 degrees. And Ken, what's the direction?
East, northeast.
Well done. All right, and then when you draw it, it would look something like this. 41 degrees, east, north, east.
I have a slightly off-topic question, but kind of not off-topic at the same time.
What?
Is it that the sun like rises in the east and sets in the west, or is it the opposite? Because I know it's one.
Sun rises in the east, sets in the west. That's why
Is that
we're
right? Or was I wrong?
that's why we're ahead of them time-wise.
What was that
It's
percent?
east rise.
41.
West.
Yeah.
Hang on, I'm writing it down. This might be like skill.
Sun rises in the east, sets in the west. All right. So that's that one. That's number one. So this is the first assignment that I gave you guys last week. And I know we had not gone over it yet, so I didn't expect you guys to be able to do it. All right. So number 2. Okay. Number 2. Angle 311. Angle 311 degrees in counterclockwise from east. Draw the representative in nearest axis form. All right. So first things first, make your labels. 0 east, 90 north, 180 west, 270 south. Okay. So the angle measurement is 311. Tell me when to stop. Okay. So it's 311 degrees. Okay. What quadrant?
Fourth.
Good. What's the total angle? What's the total angle?
Oh, the letters.
No, what's the total angle?
Oh, 311.
Yeah. Okay, so that's 311 degrees. All right. What do we know? We know what's the midpoint of quadrant 4?
315.
315, right?
Yeah.
So what's our directional here?
Southeast.
Good. Southeast. Good. Good job. Because everything up to 315 is going to be southeast. So you can draw it around. I like to draw that little circle because it helps me understand where I'm going. And it's southeast. Okay. Couple things. If I asked you, would the x coordinate be positive or negative here?
X coordinate?
Yep.
Negative.
X.
Positive.
But the y coordinate's negative.
So y would be what? Negative because it's down. Okay. Couple other things. Let's look at this. What is the angle from the nearest point? So from 270 to 311, how much is this measure? It's 311 minus 270. So what does that equal?
$41.
41 degrees. So this measures 41 degrees. Okay? But if you had to put a direction with this, how would you write this? So this is different. This is a little bit different. Okay? So in this case, you're talking about the southerly axis, right? The southerly axis is right here. What way are we moving?
Down.
The vector itself. It's moving easterly, right? So you're going to say, if you have to describe this angle in the quadrant, there's two ways to describe it. One, it's 41 degrees east of south. Okay, because you're going that way. Now, you can describe it this way too. But you really should be describing it to the closest axis, but you can do it either way. So, we know that every quadrant's 90, right? What's this angle going to measure? You can do it two ways.
49.
You can do it two ways. You can do it either 90 minus 41, or you can do it 360 minus 311. Either or gets you to the number of 49 degrees. So 49 degrees. But you're measuring that 49 degrees off the east. So it's going to be what? What are you? You are moving which way now? If you're going from east this way, which way are you moving?
Backwards.
Well, you're moving to south, okay? So what you're going to say is you're 49 degrees south of east. You're 49 degrees south of east. So when I ask on a question, describe the angle in the quadrant, this is how you would answer.
90 minus 41.
Yeah, it's 49. You can do it either way. You can either do 90 minus 41, because you know every quadrant's 90,
Yeah.
or you can do 360, because not only is this 0, but it's also 360 degrees. Because how many degrees are in a circle?
360.
360. Right? So keep in mind, your descriptors. You're going to say, okay, I'm moving south. If I go this way, I'm going east of south. Okay, and then you have what your measurement is. But if I'm moving easterly and I come down, it's going to be whatever that degree is south of east. All right? All right. Questions? Make sense? Okay. All right, so number 3. Angle 197 in counterclockwise from the east. It's represented in the 3rd quadrant. Okay? Is your x going to be positive or negative?
Just that
No, this one right here.
X is gonna be negative, Y is gonna be negative.
Yep, they're both negative. Good. Okay? And it's going to be, so the midpoint, you know, of the 3rd quadrant is what? 225. Did it make the midpoint? No, so what's it going to be? It's going to be west, south, west. Okay? And then if you have to describe the angle in the quadrant, if you're moving westerly, you are 17 degrees south of west. And if you're moving south, this angle is 73 degrees west of south, which tells you that you're moving more westerly than you are southerly. All right, questions?
Yeah.
So far, so good? All right,
Oh, so far that's not it.
that's it. No, that is it.
Oh, I was about to say.
I want you guys to work on this worksheet. That's in Google Classroom.